Good morning. Thank you, MRSP, and the different organizing committees and sponsors for this opportunity to present our work. I am Francisco Evico Jr., and in behalf of my co-authors, I present our paper entitled Attachable Exoskeletal Pressure Sensor-Based Backpack Using Selsyn Control for Postural Correction. Bad posture seems a problem, but a study showed that musculoskeletal disability is the second greatest of disability, in which case a bad posture is one of the leading causes. Back pain alone has affected 632 million worldwide, and the type of condition stated is a result of poor posture over time. A proper posture can be affected and turned to poor posture due to various factors including carrying heavy loads on the back, like backpack. It can be reduced if people have a backpack that can sense their body posture and remind the person to maintain proper posture. Bless Integrated Survey, which was conducted on Filipino workers, showed that 35% of the occupational diseases reported in companies has at least 20 workers, and the complaint was back pain. Therefore, having a system to monitor body posture is important. Thus, the authors were motivated to provide and develop the proposed system. In this research, we aim to design and implement a wearable exoskeleton device with an option that can be attached on backpacks, which can help in altering the user from poor posture and preventing possible future back problems. To do this, we need to establish a baseline for each user through calibration, which will be used as the basis for measuring the deviation of the user's posture. We need also to design a device that will implement the principle of Selsyn control to adjust whenever the user slouches, and a program that records the number of times the user slouches in order to determine if there is a decrease or increase in the user's bad posture. We expect a decrease in slouches of the user's improper posture between the first and the second half of the 2 weeks. 7 days a week testing of the device with a minimum of 6 hours monitoring per day by 40%. This is the input process output, and the system hardware consists of battery, pressure sensor, and tilt sensor. The different processes includes rectification, calibration, Selsyn control, and transducer, and the output parameters are buzzing, that is vibration, pulling of the strap, and angle monitoring. Two synchronous motors are connected with the same rotation for the purpose of pulling. And this is how the system is integrated to the backpack and shows the system components, the sensors, the stepper motor, and then the microcontroller, and the wiring connections. And this is an initial installation of the system, which is incorporated to the backpack. The system will be supplied by a battery that is charged through a 220 volts AC. The microcontroller will then be powered by the battery and receive input coming from the sensors, stepper motor, accelerometer, and is generated by the movement of the user. The Selsyn motors and vibrating motors will be activated depending on the data coming from the sensors. To use the system for the first time, calibration process will be done for a particular user by the physical therapist. After turning the power switch and the battery is charged, the flex sensors will be activated. Then it will determine if there is any pressure. To acquire the calibrated value like pressure and angle, The physical therapist will instruct the subject to obtain a proper posture according to his instructions. Any deviations from the calibrated value will trigger the piezo speaker to alarm to inform the subject to return to its proper posture. Afterwards, the device will start to operate according to the subject's calibrated data. Once the system is calibrated, the device will start monitoring if the subject is in proper posture or slouching. When the subject slouches, an alarm will be heard as a passive reminder that he is slouching, and that reminds him to go back to the proper posture. If the user does not correct himself, after 7 seconds, the pulling motors will activate as an active reminder to force the subject to correct his posture. So the user must follow the pull of the motor in order to stop the motors. This process will continue until the user turns off the device. After 2 weeks, the reduction of the number of slouches per day for all the subjects shows a significant reduction. As we can see here, after 7 days, subject 4 has already achieved 36.84 reduction of slouches. The pre-test was conducted by the physical therapists through looking at the pictures sent by the subject in order to determine the subject's posture and condition. The post-testing for the subjects in turn did not occur due to the physical therapist needing actual physical contact with the subjects in order to test the difference brought by the device. So this shows the difference between the first half against the second half of the testing. Among the 4 subjects, none was able to attain the number of slouches to more than 40%, which is the aim of the study, which means that all 4 test subjects failed to reach the objective, with one of them only missing a mark by a few points. But the 40% reduction presented is tailored for the original 4 weeks time-bound that was cut short because of the ongoing pandemic to 2 weeks. Nevertheless, it is outstanding that subject 2 was able to almost reach the required reduction of the frequency of the slouch within the stated reduction tailored for 4 weeks within 2 weeks only, and only missed a mark with just half a decimal left. After the testing period, the researchers were able to analyze and compare the data and concluded that the 40% target reduction from the first week to the second week was not met for most of the users. Target trial time and dates were also accomplished. The users had to finish the trial within 2 weeks with an everyday trial that consisted of using the device for at least 6 hours every day. Overall, the prototype was able to accomplish what it was designed and created for, which is to reduce the amount of slouches the user does, and to improve the user's posture, albeit not being able to reach the target reduction. The results demonstrated by this system can be used as a pilot study in conducting future work in the search for a wearable device that can help subjects in maintaining proper posture, thereby reducing musculoskeletal disorder. So here are my references and my contact information. Thank you very much.